Hello ladies and gentlemen, Miss LaJoy here. Today we are going to talk about slope. So slope is how we determine how steep a line is. And I need you to know that we read a graph from left to right. So in this direction. That's going to be important. Now I want you to be familiar with the kinds of slope that we will see. So first of all, let's change my color a little here. So first, if we have a slope that, or if we have a line, I'm sorry, let's just show you lines here. So if I have a line that goes like this is a positive slope. Remember, we're reading our slopes and our graphs from over here, starting on this side and going in this direction. So because this starts down here and goes up, that's a positive slope. Now over here, let's see another line that goes maybe like this. Okay, because this line is going down when we read our graph from left to right, this is a negative slope. Now we also, at some point, we will see lines that do this. That's just a horizontal line. It has no slope, so horizontal lines have no slope. They can't. They're just horizontal lines. It's like a flat road. And then we'll also see some vertical lines. So if we see a line that looks like this also doesn't have a slope because it's just going straight up and down. So when we have a vertical line, we say that they are undefined. Vertical lines are called undefined. Okay, so those are the different kinds of slopes. I would really like you to pause the video and write this down because this is a good reference for you to come back to. So positive slopes, negative slopes, horizontal lines, and vertical lines. So I'm going to move on. We're going to investigate how we classify our slopes. So let's clear this. Oops. Clear that. Let's pause for a moment. All right, I'm back from my technical difficulties. So we are going to look at how we measure slope. So in order to precisely classify the kind of slope that we have to measure it. So slope must be measured. And the way that we do that is by looking at the distance between the points on a graph. So we're going to use grid here, and I'm going to put some points on. So if we have points that go from, I'm going to draw my points on, so here, and right here, and then right there. Okay, so you can see that there are 3 points on this graph. I'm going to connect them with a line. So we'll show our line here in yellow. So starting from the first point, passing through those points. It's not a great line because I'm trying to do this on my computer, but there's our 3 points, okay? So the way that we measure slope is to look at the distance between these lines. So slope is defined as rise over run. So m is what we use to represent slope, and we measure it by the rise over the run. So the rise is going to be how the line moves up and down. And the run is going to be how it moves from side to side. So if we look at this graph here, and we look at our first point, to get from the first point to the second point, we are going up from 1 to 3. So we're going up by 2, and we're going over by 1. And if I go to the next point, again, I'm going up by 2 and over by 1. So this has a rise of 2 and a run of 1. So what's important to know here is that lines are constant. So I could pick any 2 points on the line, and that was kind of proven here by going from this first point to the second point and going from the second point to the third point. I'm always moving at the same rate. I'm moving at a rate of up by 2 and over by 1. So this is my rate. This determines how steep the line is, how steep or how shallow the line is. So this line will end up being pretty steep. Let's draw it in purple so we can see it better here. Oops, not great again, but it's a steep line. If that was a hill that you were walking up, that's a pretty steep hill. So we're going up by 2 and over by 1. So that is the rate that this line is moving from one point to the next. So when we write this is the slope of our line. So the slope is 2 over 1, or we can just say 2. Now the reason for that is that, remember, with whole numbers in math, there's always that imaginary 1 underneath the 2. That applies to slope as well. We don't have to write 2 over 1. We can just write 2, because any whole number, when we're looking at a slope, we know that there's an imaginary 1 underneath it. Because if there wasn't a 1 underneath it, this line would just keep going up by 2, up by 2, up by 2, up by 2, and it wouldn't move over. That's not a slope. That's a vertical line, right? And that's not what this graph is showing. This graph is showing a line that goes up by 2, over by 1. So we can write that our slope is 2 over 1, or we can just write 2. If you're faced with a question that says a line has a slope of 2, I need you to remember that there is an imaginary 1 underneath that 2. So when you work on whatever question it is, you have to know that your line is going to be going up by 2, but also over by 1. Okay? So that is our slope. That is our rise over run of this line. So let's take a look at some other examples. All right, so I'm going to change my color here. So let's look at another series of points. So if we have a point here, and there, okay, so these points here. I won't draw the line because it's just going to make it a little more difficult for us to see here. But you can imagine that this line is filled in. So following these dots, starting from the left of the graph, moving towards the right. So we're starting right here at this point at 1, positive 1. So to go from my first point to my second point, let's see how this line is moving. So this line is going up by 1 and over by 3. Again, if we look from here, we're going up by 1 and over by 3. So this is up 1 over 3. That means that the rise of this line is 1. The run of this line is 3. So it rises up by 1 and it runs over by 3. So the slope is 1 over 3. Okay, so our slope again is dictating how this line is moving. But what if this line isn't moving up? So what if this line is going from, so we're starting, let's say we start right here, and our next point is right there, right there. All right, so this line here, if we start from our first point on the line, remember we read our graph from left to right, so to get from our first point to our next point, we're not going up though, we're going down, aren't we? From here, we go down by 2 and then over by 3 to get to the next point. Again, we're going down from here by 2 and over by 3. So this is down 2 over 3. So the rise of this line over the run, the rise, it's not really a rise though, is it? Because it's going down. So that's a -2. And it's still running, it's going over by 3. So this line, because this, and I'll draw this one so we can see, this line starts up here and it moves this way. Whoops. It's not a great line. But you get the idea. It starts at the left at 4 here and it goes increasingly lower. So this line is a negative slope. So a negative slope, we can recognize a negative slope because we have a negative number. If we have -2 over 3, that means we are going down by 2 and over by 3 when we read our graph from left to right. So if you see a negative slope, that means that we are going down. We're going down the mountain. We're skiing, we're snowboarding down the mountain. So what we're going to look at now is using a graph to measure rate of change. So slope as rate of change. And this makes it a little more practical for you because we're kind of putting data to work here. So a graph can be used to show, for example, speed. So the formula for speed is S equals D over T. So D would be the distance and T would be the time. So if we are looking at, for example, an athlete, so this graph is going to have the distance right here. So we'll say distance in kilometers. And the bottom of the graph is going to represent the time in minutes. So we're looking at measuring someone's speed based on a line on a graph. So if we label this graph here, So always right in the corner here, this is 0, right? So these kilometers will go up by 1. So 1, 2, 3, 4, 5, 6, 7, 8. All right, and across the bottom, we're going to measure time in minutes. So I'm going to put, let's say 10 minutes here, 20 minutes here, 30 minutes here, etc. All right, so there's our graph set up for kilometers and minutes. So what we want to do now is I'm going to plot a point here. So if we have a point on this graph to represent this data at this point right here, okay, this graph shows that, and let's do our line as well. So starting at 0, following this line all the way up to this point where I've drawn the dot a little bigger. So to find the slope of this data, we are going up from 0. How far are we going up? We're going up by 5 and over by, what does our graph at the bottom read? 20. So this goes up 5 over 20. That makes this a slope of 5 over 20, or a speed of 5 distance over 20 time. So I can write it both ways. So we can say our rise is 5 and our run is 20 for a slope of 5 over 20. We can say our speed equals our distance, which is 5 kilometers, over our time, which is 20 minutes. Now we can make this even more precise because we can take our top number, divide it by our bottom number, and 5 divided by 20 is 0.25. So in the context of this question, if we're looking to find the rate of change for this athlete, they have traveled 5 kilometers in 20 minutes. That means that their speed is 0.25 kilometers per minute. So speed. So therefore, the rate of change is 0.25 kilometers per minute. All right, so we have taken the idea of slope and applied it in a real world context because we're looking at the speed that this athlete is traveling. If they travel 5 kilometers and it takes them 20 minutes, their speed is 0.25 kilometers per minute. Now the last thing I want to look at as part of this unit is what we call first differences. So first differences, we use that to determine what kind of a relationship we have. So used to determine the kind of relation. So we can have linear or nonlinear. So you may have guessed what this means, but linear means line and nonlinear means not a line. Okay, so we can, using first differences, determine if our graph is showing a line or not a line, even without graphing, which is pretty cool. So I'm going to draw out a table of values and then we're going to analyze that table of values. So I have an X and a Y. this table of values. And let's say that my points here are 0 and 5, 1 and 6, 2 and 8, 3 and 12. So what we want to do here is, first of all, we want to take a look and see if our x values are constant. So if our x values are going up evenly. So the difference between 0 and 1 is 1. The difference between 1 and 2 is 1. The difference between 2 and 3 is 1. So yes, our x values are constant. So now we can take a look at the y values and we can determine our first differences. So I'm going to write first differences. And we're going to look at our differences. So looking at our y values, to go from this y value to this y value, we have 6 minus 5. So notice that I'm using the second and subtracting the first number from it. That's how we're going to determine the difference. So 6 minus 5 is 1. Now I'm going to look at the next set. 8 minus 6 is 2. Well, I already know now that it's not linear, but we'll do the rest of it. 12 minus 8 is 4. So in order for a relation to be linear, all of the first differences have to be equal. So are these first differences equal? No, because I have a 1, a 2, and a 4. So in order for a relation to be linear, oops, I'm in trouble with my pen today. All the first differences must be equal. So since these first differences are not equal, this is nonlinear. So we can tell we don't even have to graph all of these coordinate points on a graph like I have been doing. I've been putting those dots on the graph. We don't have to put the dots on this graph because we know just from looking at the table of values that this is not a line. It's not linear because our first differences are not the same. They're not equal. Let's do another table of values. So this table of values, let's say we have, so I've got my x and my y. Make this table of values here. So let's have -5 and 8, -3 and 4, -1 and 0, 1 and -4. All right, so the first step is to take a look at our x values and make sure that they are constant, because if they're not constant, we can't do first differences. So the difference between -5 and -3. To go from -5 to -3, I'm going up by 2. To go from -3 to -1, I'm going up by 2. Say +2, +2. To go from -1 to +1, again, I'm going up by 2. So yes, these are constant, so we can proceed to looking at our first differences. So let's look at first differences. So our first differences, again, we're going to look at the change between the y's. So if I have my 8 and 4, if I say 4 minus 8, I get -4. next to, if I say 0 minus 4, I get again negative 4. And if I have negative 4 minus 0, again negative 4. Therefore, this is linear. This is linear because the first differences are equal. Right? That's really important. So we have been able to determine, just by looking at this table of values, that yes, this is a line, and we didn't even have to graph it. So yes, it's a line.